This is Pre-Calculus B, Unit 4, Polar Coordinates and Functions, and Lesson 7, Complex Numbers in Polar Form. And we're going to get into complex numbers. This is a topic that you may recall we covered in some depth back in Semester 1, near the beginning of the semester. You recall the complex plane consists of a real number line, the x-axis, and an imaginary number line, the y-axis. So real number line, the x-axis, an imaginary number line, the y-axis. And we did operations on complex numbers and so forth. So here's y, well not y, yeah, and x. This is the real axis, and y is the imaginary axis. And we can graph the complex number z equals a plus bi. A is the real part, and b is the imaginary part. And the combination of real and imaginary makes for what we call a complex number. Okay? And we graph A and B as the x-axis for A and the y-axis for B. So this coordinate here is AB. Okay. All right. Now, as you well imagine here, we can superimpose a triangle here, a right triangle. Okay. And the width of the right triangle is A, and the height of the right triangle is B. Okay. R is right here, and theta is right here. So here's the connection between polar form and rectangular form for the triangle. So let's take an example here. I'm going to add a layer so that I can draw on this and revert back to it. Let's let z equal, the way I've got it here, 2, 4, 5 plus 4i. Okay, and we're going to rewrite this in complex form. So in rectangular form, it's 5 plus 4i, or in rectangular coordinates, 5, 4. We're going to express it in polar form. So we're going to express it in r theta form. So r, by the Pythagorean theorem, r squared is a squared plus b squared, because the Pythagorean theorem applies. Well, r squared is 5 squared plus 4 squared, which is 25 plus 16, which is 41. So r is the square root of 41. Okay, and we'll go ahead and get an approximate. Well, we'll leave it. We'll leave it. Square root of 41. Okay. All right, and theta. So we can use the tangent ratio. Tangent of theta is b over a. So theta, or tangent of theta in this case, is 4 over 5. So theta is the arctangent of 4/5. Okay, now let's get some approximate answers here, so we can at least picture what's going on. Oh, Desmos, not des least, but Desmos, Des does the most. All right, So square root 41, 6.40. Let's go to the 10th place, 6.4. And arctangent of 4/5. Okay. Now I happen to be in degree mode, I believe, right now. But let's go in radians here. Well, we'll stay in degree. We'll stay in degree. Okay, but do be aware of which what your calculator is set to. So 38.7 degrees. Okay, and there's a couple of ways we can express this. We can express this in polar form this way. So z equals in polar form r theta. So r 6.4 theta 38.7 degrees. The problem with that is there's no way, unless you happen to know which one you're in, whether that's rectangular or polar. So here's another common way. Z equals, and then r times cosine theta plus I sine theta. Okay, r cosine theta plus I sine theta. This comes from the idea of simplifying or converting from polar to rectangular. If I know r and I know theta, then sine theta is b over r, and b is r sine theta. And cosine theta is a over r, so a is r cosine theta, and factor out the r. Okay, so here's a relationship. Before I get to this, let me throw up some formulas here. So sine theta equals b over r. So b is r sine theta. And cosine theta is a over r. So a is r cosine theta. Okay. And now z becomes a plus bi. A plus bi. And a plus bi is r cosine theta plus r sine theta times I. Factor out an r, and we get this, r cosine theta, and we like to write the I before the sine, so we know it's not part of the argument for the sine function. Okay, so there's a formula that you're going to need to remember, r cosine theta plus I sine theta. This is used so frequently that in mathematics we recognize this in shorthand notation as r cis theta. And it's shorthand for cosine plus I sine. Cosine plus I sine. But do be aware, you can use r cis theta, but do be aware of exactly what it means. Okay. All right, so in rectangular form, or in polar form, it's better to express this as z equals 6.4 cis 38.7 degrees. Okay, hopefully that makes sense. So we've just converted from rectangular form to polar form. Now we need to be able to do the opposite. And the opposite actually is quite easy because it's built into this formula right here. Okay, so let me delete this layer here and add a new layer. Okay, and let's say we happen to know r, and we're going to have to disregard the grid here per se. But let's say that r is 5 and theta is 36 degrees. Okay. And what is z? So z equals r cis, or r cis theta, right? That's what we just said. So z is 5 cis 36 degrees. To convert it to rectangular form, all you got to do is this. Z equals 5 times cosine of 36 plus I sine 36. Okay? And this is a calculator question. Here, cosine 36. So 5 cosine 36 is 4.05. 4.05 plus I sine 36. I sine 36. So 5 times sine 36. Fat finger. Okay, 2.94. So 2.94i. Hopefully that makes sense. It's built right in. 5 cosine 36, 5 sine 36. 5 cosine 36 is the real part. 5 sine 36 is the imaginary part. Okay, so that's how you convert from polar to rectangular. And this is going to become more important once we do operations on complex numbers, because certain operations are easier to do in one form than the other. Hopefully that helps.